Hello guys, welcome to my home again. I know that there's very abstract concepts but that we're learning in this lesson. Two of them are phase and coherence. And today while I was listening to music, I had an idea on how to explain it in a different way. Okay? So to do that, I'm going to use two metronomes. I place the bass, so metronomes are my best friends. Just let's assume, well, a metronome, it just gives you the tempo. In this case, is 120 beats per second. So let's assume that in every beat, we are in the maximum value of our wave. Okay, so it's gonna be tick, 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 tick. Great. So what can it happens if we mix two metronomes? These two are in the same beats per minute, so we can say that they are in the same frequency. So I'm gonna play both together. Of course, the beat is in the same time. Okay. In other words, waves are reaching the maximum value in the same time. That means that they are in phase and that they are coherent because they have the same frequency, the same beats per minute. Okay, we are here. But what can happen if they are not playing at the same time? Let's assume that we're gonna play one a little after the other one. In other words, I'm gonna move the graphic a little to the right, the second wave. Okay, this still playing, and I'm gonna play this in a different time. Let's have a clearer difference. There we have. Well, clearly there's now two beats that are separate, very clear, but there's still some rhythmic pattern. It's actually a kind of groovy. It makes me want to dance. That's because they are not in phase. The maximum values are not reaching the same at the same time, but they are coherent because they're gonna have that difference of phase difference during all the time. Okay, so if you see in the graphic, practically there's this difference between this highest point and this other one. So they are not in phase, but they are coherent. And if you think about, they're gonna keep playing forever like this, and they're gonna have this phase difference. So they will never have a phase. They will never have the same peak at the same time. But they're gonna be coherent, like two parallel lines. They will never get together. Okay. So what would happen if we don't move this? We don't move the position of this, but we change the frequency. What's gonna happen? In other words, I'm gonna keep this metronome in 120 and I'm gonna change this one. Okay, let's change it to 145, 46. Just listen. It's a little chaotic now. It's not a rhythmic pattern. I don't want to dance anymore. That's because they're not coherent anymore. Okay, in the graphic, as you see here, they are in phase because both maximum values are at the same time. But if we move here to the next one, they're not in phase anymore. Look, this is a little more to the right. what is gonna happen in the next maximum value? The difference is gonna be even higher, and it's gonna be like that until what's gonna happen? At some point they're gonna be in phase again because their difference is not constant. So at some point in the future they're gonna match again the two bits. Okay, so they're gonna be in phase, but just for one bit, and then we'll have to wait again. So they're not coherent. In this case, the waves are not coherent. Okay, so this is important to know because we know that to have an interference, we need waves that are coherent. I hope that was useful. Bye, guys.